Welcome to C# for Crestron Programming. Reflection in Crestron Programming is identical to C# reflection. We can leverage a plugin architecture to increase the flexibility of your programming by leveraging it for drivers, as well as additional functionality that can be added at runtime. The example code is available for download. Reflection is greatly simplified when used with interfaces, and this is where we'll start our project. The interface defines how we are going to use and communicate to the loaded libraries. We need to make this decision first, as the program and all libraries that will be reflected into that interface must use the same interface. Here we define the properties and methods used, and we're going to define an event with a custom set of event handler arguments. This class will be included here in this library, as it will need to be used by the libraries and the program, as well as the interface. Including it here simplifies coding and ensures it is available in every project that will use this interface. Next, we will go to the driver library we are going to use with reflection. The very first thing we need to do is add our interface library as the reference and add the using statement. In our class, we need to inherit the interface by adding the interface to the end of the class with a colon. When you do this, it will complain that it is not complete until you add everything the interface has defined into your class. We then add our code to complete the class's functionality. For example, this one is a TCP/IP client for a fictional projector that will have an emulator running on the same processor. We also define an event to let our program know when we get a response back from the projector. This event uses the same event arguments as we defined in the interface library that was created. Aspects of threading, TCP/IP client, and event handlers are covered in more detail in an earlier series of videos. When we have this library complete, we can compile it and move on to our main program. This Crestron control program has been simplified for clarity. Your control program must have the library for the interface added to its references and add in a using statement. Remember, everything that is going to be used in our plugin system with reflection must use the same interface. In the initialize system method, we're going to load our library as an assembly. Here I am keeping the library in the NVRAM folder on the processor. Once it is loaded code, we will iterate through all types in the assembly and print them to the console for viewing. Because we wrote this library, we know there is a single class, and we can assume that the first type loaded is our class. But checking to be sure, anyways, with an if statement. We now use the reflection library method to create our instance of the class inside the reflected library, and from this point on, because we leveraged interfaces, we can treat it as if the class was part of our project. We set the address, port, and subscribe to the library's event. And the rest of the code is our demo X panel for ease of testing. Let's compile and upload. We need to place our library in the location our program expects it to be. If it does not find it, it will throw an exception. It would be a good idea, in production code, to add checks to see if the file is there before attempting to load it. Restart our program and launch the X panel to test. We can see on program load the library was reflected in and an instance created, as well as the class inside is listed to console. At this point, we can try and connect and send commands to our projector and look for responses. We have successfully created a plugin architecture by leveraging reflection with interfaces. This empowers your programming to be able to have dynamic scaling, as well as changing functionality and hardware interfaces without having to recompile and reload the program. Thank you for watching.